Testing, testing. All right. Oh, it feels good to be here. I feel like we got to stay connected. You know, we're moving on to the second half of the course, and it'll be good to have just new videos and new customized content for our needs. I'm just going to go over uh, some things today that should be useful. You know, maybe tackle some questions that may come up. We will also touch on the midterm practice exam, and I know that one of the most important chapters that I always talk about is chapter 6, and that's right after the midterm. Now the midterm, we still got some time, all right? So if we go into the files and we pull up the calendar, we will see that we are here, and it looks like the midterm is gonna start next week. So it's actually pretty quick. Yeah, maybe we will still have a review, and maybe that midterm will open up right after that. Right after that review, we can still have that going on. I guess the other review that we had scheduled, it was scheduled for the 9th. So maybe that's when we'll do it next week, not Wednesday, but next week, Tuesday. We can go over any last minute questions and tips, and then that's when the midterm is going to open up. And let's keep in mind that it opens the 10th, but it closes the day after. So, and that's pretty standard. It'll be open all day Tuesday, or all day Wednesday, the 10th, and then close on the 11th at midnight. So you have 48 hours. So within that window, it's a 2-day window to take that test, and then we will grade it all. And if there are any issues, I know sometimes students don't mention this to me, but if there's any issues with rounding or partial credit and the system, you feel a little cheated, or maybe you want me to take a look at something, reach out to me about that, and I don't mind going in there and trying to scavenger a point or two somewhere. And sometimes when you have these little quizzes with 15 points, you know, 1 point is already almost 10%, and you know, more than 5%. Uh, so, you know, a half a point would be pretty significant, especially if you're on the borderline. All right, if you're near 89% or 79, and sometimes students will just be, oh, screw it, I'll just take the whole thing over again, and that's fine too. In fact, taking it over again is probably gonna be the better thing because you tend to learn it better. It's that retainment piece, and that's one of the reasons why I give opportunities to take things multiple times. It's not just a thing this semester, but that's kind of just one of my philosophies. So I'm going to be monitoring the chat and make sure my sound, it seems like my sound might be delayed slightly. All right, that's good to know. I didn't know my sound was delayed. Let me make sure that it's not delayed anymore. How's it going now? Okay. All right, so it shouldn't. Looks like the stream should be going pretty well so far as the parameters that I'm seeing, and it's even on one of those low bands, to where it's real time. All right, so we're getting real feedback instantly. I don't think there's much delay. There shouldn't be much delay, but if there is a delay, let me know, and we will get that fixed. And this is being saved and recorded, so you know. Um, now, okay, so here's the thing with the practice midterm. It is chapters 1 through 5, and I think 5.3 we're going to pull off. So 5.3 is just going to be one of those chapters that we're not going to really do. And let me open up the text real quick, and let's just kind of spend a little bit of time talking about chapter 5, sections 1 and 2 real quick. So it's a really good chapter. I mean, it's kind of a combination of probability and um, statistics put together. And that's going to be really interesting and useful for chapter 6 when we move into chapter 6. All right. Now I'm running into a technical issue with my graphing calculator not being available. I only have a physical one here, but not one embedded into the screen. Um, but hopefully we can get that. That shouldn't be a problem. I can get that resolved by our next meeting next week, Tuesday. All right. So let's take a quick look at this, and maybe we can see if we can go full screen on this somehow. Wow. Yeah, that's all right. All right, so we're going to get into something interesting, and it's not that bad once you start to think about it. But I think that it does get deep when you when you first take a glance at it. It gets a little deep, but when you start from the beginning of the basics of it, you realize what's happening, and that's really what this is about. So it's like, for example, um, flipping a coin a bunch of times, right? And so here's what's happening um, in chapter 5. You know, you may have seen this case where we have a frequency distribution table, a probability distribution, and all that. But in chapter 5, we're going to create a theoretical model of the expected results. And then we're also going to be able to calculate the mean and the deviation from this table. So let's just kind of jump into this part, all right? And we'll go through this section. The sections are only a couple of pages long, so we usually go through those pretty quickly. Um, so again, this is based on probability distributions. So first thing is we need to understand these two things: a random variable and then a probability distribution. So a random variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. And then finally, a probability distribution is a description that gives the probability of each value and is often expressed in a format table, formula, or graph. You do have to know the difference between a discrete random variable and a continuous random variable. And I will just say a discrete, think of a whole number, something that can be counted, like eggs, cars, you know, the number of cars on the street or at the stop sign, the number of eggs a chicken will lay, the number of page in a book. Those are all discrete variables, and if we randomize it, then it would be random. Whereas continuous, we're talking about decimals, fractional parts, things of that sort. All right, let's look at this. So here are some requirements in order to have a probability distribution. These are the 3 requirements. Every probability distribution must satisfy each of the following 3 requirements. There is a numerical random variable, and it's either discrete or continuous, but it is numerical. The sum of all the probabilities will equal 1, and then also the probabilities must be between 0 and 1. And this goes without saying, because probability can never be less than 0, it can never be more than 1. It can be 0, it can be 1, but it's always inside this inclusive interval. So let's look at an example. It says, let's consider this tossing 2 coins with the following random variable. So X is the number of heads when 2 coins are tossed. And so that would be a random variable because we're not always going to get a heads. I mean, when we get a heads, it will be random because we're tossing the coin. We're tossing 2 coins, and we're going to count the number of heads. The above X is a random variable because its numerical values depend on chance. With 2 coins tossed, the number of heads can be 0, 1, or 2. And we can look at this table. So on one side we have X. X is our random variable. And in this case, the number of heads. It stands for the number of heads when 2 coins are tossed. You're either going to get these 3 different outcomes. You're either going to get 0 heads, 1 head, or 2 heads. And also, our probability distribution comes with the probability of each event happening. So that the probability of getting 0 heads when you toss 2 coins is 0.25, or 1 out of 4. Probability of getting 2 heads, or 1 head out of the 2, half. And then the probability that they're both heads is 0.25. Notice that the probabilities total 1, and that's the other requirement. And then the third requirement is that the probability is between 0 and 1 inclusively. So and they're clearly between 0 and 1. Notice the X, these are on the left side, we're not talking about the probability. That's the right side. On the left side, we're talking about the random variable, all right, the value of the random variable. So it's either 0, 1, or 2. So in this case, this is clearly a probability distribution. And then they even go as far as to say that the random variable X is a discrete random variable because it has 3 possible values, 0, 1, and 2, and 3 is a finite number. So this satisfies the requirement of being finite or countable. All right. Now, sometimes you might see 0 plus on one of the tables. That just means it's so close to 0. It's not quite 0, but you can round it off to 0. So 0 plus is kind of like 0, but there's like a little bit of change, some kind of infinitesimal value on the end there. All right. Here's another distribution. Here's another way to show a probability distribution, and this time we have it in a table. Okay, this is the same thing as this graph is the same thing as the table. So they're like a one-to-one correspondence between this probability table and the other thing we call the other table that we saw. So pretty straightforward. All right, and let's keep going. So here's a question. Hiring managers are asked to identify the biggest mistakes that job applicants make during an interview. Table 5.2 is based on their responses. The question is, does 5.2 describe a probability distribution? Well, first of all, the X values are not even numerical. And then the probabilities on the right, well, they're all between 0 and 1. That's good. But the sum of those probability values is more than 1. That's a problem. So it says table 5.2 violates the first requirement because X is not numerical. And then also the values of X are categorical. They're not numbers. And because the three requirements are not all satisfied, we conclude that 5.2 does not describe a probability distribution. All right. So when we have a probability distribution, this is how you would calculate the mean. And it's really just the summation of, let's go back to our original one, the summation of this times that. So 0 times this, 1 times this, 2 times that, and if you add it all up, that's the mean, and that is also the expected value. So let's look at that. The mean for the probability distribution, which is there's the parameter, that stands for the mean, is equal to the summation of all the X times the probability of X. The variance is going to be given by this formula. So once you know the mean, you're going to subtract the mean from the X, square it, multiply that by probability, and then also the deviation there. It's just going to be the square root of the variance. Now, the calculator will calculate the mean and deviation for you. All right? All you have to do is put the data in a list. So this will be one list, L1 and L2. And if you put the data in the list, it will automatically calculate it for you. You would do one var stats, and it will give you the mean and the deviation. And if you have the mean and the deviation, the variance will be pretty easy to get as well. You would just square the deviation to get the variance. So that's kind of how we do it. Now the expected value, well, it turns out the expected value of a discrete random variable X is denoted by E, and it is the mean value of the outcomes. And so here's an example. It says finding the mean, the variance, and the standard deviation. And that's based on, I guess, the probability of flipping 2 coins. Pretty straightforward. Nothing unusual or weird about this. Basically, they had the table, 0, 1, 2. There's a probability. Now, if you multiply these two together, you're going to get 0, 0.5, 0.5. And then if you just total that column up, you're going to get the mean. And that mean represents the discrete random variable, X is 1. So this is what you can expect on average. This is the average of what you would expect when you toss 2 dice. You would expect 1. The variance turns out to be 0.5, pretty straightforward. And again, once you have 0.5, you can take the square root of 0.5 and you'll get the deviation. So this sums it all up. The mean is 1. You can expect to get 1 head out of when you toss it. It will vary though, because you're not always going to get 1 head. And then the standard deviation is 0.7. Now, the standard deviation is useful because by the range rule of thumb, you can take the mean and add 2 deviations from it. So pretty straightforward stuff. You probably saw this on the homework. There were some problems like this on the homework, probably. And we can look at some of those as well. Yep, it all can be done on the calculator. Identifying significant results or not. Well, we know that the number of heads is around 50. So anything close to 50 or half of the number of times you tossed is going to be, you know, what you would normally get. Probably nothing too significant. It's all pretty straightforward. As far as the, let's see, the roulette and the these odds here, we don't do problems like that. There's not going to be a problem like that on the midterm. All right, just looking through everything, making sure everything is good. All right, let's take a look at maybe some of those homework problems. Oh, the first question is just the table to the right lists the probabilities for the corresponding numbers of girls in 3 births. So we have the random variable of the number of girls being born and in 3 births. What is the random variable and what are its possible values? And are its values numerical? Well, the random variable will be number of girls. The values are 0 through 3. And it is numerical. It's discrete. I like this one. I like D. Yeah, that one's pretty straightforward. I guess this is more like a warm-up type of question. There you go. So it's warming you up, and then they get progressively harder. Sometimes you can click on help me solve this, and it'll just walk you through. Well, some of them have it, but sometimes that's just a pain. Now here's where you need to classify and identify whether you're talking about continuous random variable or not a random variable. So the number of people in a restaurant that has a capacity of 200. The choice is it is a discrete random variable, it is a continuous random variable, or it is not a random variable. Yeah, well, hey, the number of people in a restaurant, we're assuming the restaurant is open. It has a capacity of 200. We know people is all can be counted as a discrete value. Okay? So I like A for that one. The square footage of a house. Well, a house would definitely have square footage. The question is it discrete or would it be a continuous value? Remember now, continuous is a fractional amount or some sort of a number that needs to be measured. And it all depends on the instrument that you're using. You know, this, I don't want to get too philosophical or, you know, into a paradox, but if I go weigh myself on a scale, I'm going to see my weight only as good as the instrument can tell me. All right, like I might have a digital scale and it may round off to the nearest tenth. But if I go to a doctor's place and they have one of those big ones that I stand on, hey, they might be able to tell me my weight to the nearest hundredth. So it's different. I never really know my true weight, all right, because it's a continuous value. You know, you round it off. You can round it. You can keep rounding off to an infinite amount. So you know, it's just like pi. Nobody knows what pi is, but we do know that if we just round it off, then we're good with it. We can just say, hey, to the nearest pound, I weigh blank. This number. That's what this reminds me of. The square footage is something that needs to be measured. So for that reason, I'm going to go with continuous. All right. The eye color of people on a commercial aircraft flight. Now, that would be a random value, but it's not going to be a discrete or a continuous because those are dealing with numerical. So we're going to have to just say it's not a random variable. But it's true that like the eye color would be somewhat random. I'm going to go with not a random variable. Okay. So yeah, I mean, you're just going to kind of click on some. The amount of rain, again, that's something that needs to be measured. The amount of hits to a website, the amount of light bulbs that burn out in the next week in a room. Okay. Let's keep going. This problem reminds me of the one that we just did, so here, let's see what's up with this one. And sometimes what you can do is click on this table and it'll open it up so you have a better view of it. Now this can be done, like if they say, hey, calculate the mean, this can be done on the calculator. Again, you have two columns, so you have to enter both columns in as a list. So this will be my L1, this will be my L2, and then you just go to one var stats, hit stats, calc, one var stats, and then type in L1, L2, and it will give you the mean and the deviation. Everything can pretty much be done in the calculator in this class. Does the table show a probability distribution? Select all that applies. Well, in order to figure that out, basically I would just add up the probabilities. If they all add up to 1, then I would be like, yeah, it would be. Now, does it add up to 1? I don't know. It kind of looks like it does, though. I mean, already I'm at 64, and like that's like 15. 64 and 15 is already at, well, it was like 80. Maybe it's short. Maybe it's short. Maybe it doesn't add up. The probabilities does not equal 1. And then also it says 5 males with the X-linked genetic disorder have 1 child each. The random variable X is the number of children among the 5 who inherit the X. Okay, so that is definitely a random variable, a random discrete variable, the number of kids born that has that gene. And then determine whether the probability is defined. So it's just a matter of adding up the probabilities. Now, if I did open it in Excel, for example, I probably could just type in sum that column and I get 1, exactly 1. So hey, that's good. I don't know why I didn't get that. Oh yeah, no, I miscalculated. Yeah, 64, about 65, and then another 15 is already up to 90. So that's yeah, that's going to be 1. So I'm going to go with yeah, and we got it right. Find the mean. Well, again, you do 0 times this, plus 1 times that, plus 2 times that, plus 3. You're going to add it all up, and you'll get the mean. It's pretty straightforward. And it probably would be about 2.5. I mean, if I just look at it, because it just looks so symmetrical to me. Like the data, it just looks so symmetrical. So like if I took a wild guess, I didn't calculate. I don't have my calculator do this. But if I just take a wild guess, it's gonna be 2.5, which is right smack in the middle, and that's because it is perfectly symmetrical. So it's not going to be that hard to do. Now, you're okay. You're not going to be able to do standard deviation in your head. That's going to be kind of hard to do. So let's move on. Let's look at some more problems, and then what we'll do is we'll preview 5.2 as well. Okay. Some pickup line. Ted is not particularly creative. He uses the pickup line. If I could arrange the alphabet, I'd put you and I together. The random variable X is the number of women Ted approaches before encountering one who reacts positively. The random variable X is the so determine if that is a probability distribution. So all right. Now this doesn't. Now clearly the probabilities does not total 1. So he doesn't have a probability distribution. It is now the probability is between 0 and 1, but if you take the sum of the probabilities, I think that's probably the only thing wrong with it. The random variable was pretty good. Let's move on. And if it's not a probability distribution, then it's not gonna. Then you can't calculate the mean either. So I think that the ones in the beginning are kind of just pretty easy. There's not that many questions, so you can kind of just preview them all. Find the probability of getting exactly 6 girls and 8 births. Oh, and they actually give us the probability distribution. So exactly 6 would be right here. So I would just do, hey, 0.101. I'm just wondering, is it that easy? Is that all they wanted us to do? I thought that they wanted the theoretical probability. Then we'd have to do some combination calculating. And that's where it gets sometimes hard to comprehend what's happening. But I mean, if they're giving us the probability distribution, and they say, hey, exactly 6, so that's going to be at 0.101. That's what I'm going to say. Let's let it be easy. Okay. So find the probability of getting 6 or more. So then we're simply going to do 6, 7, and 8. We're going to add those together. And if I add it together, that's going to be 8, 3, 1. So 0.138. And then the question is, which probability is relevant for determining whether 6 is significantly high number of girls and 8 boys? Well, that's one of those questions where you pretty much have to kind of think your way through this. Like, what do they really mean? Um, I think it would be nice if it would be nice to know the cumulative probability from 6 or more. So if someone says, hey, which probability is relevant for determining whether 6 is significantly high number of girls and 8 boys? If we just do the exact 6, hey, that'll tell us there's a 10% chance. But if we calculate the probability of getting 6 or even more than 6, this puts it in perspective. Yeah, probability is even a little bit greater. So if someone asks, hey, which probability should we use to determine if 6 is significantly high number of girls and 8 boys? Well, it's not. 0.138 is really not significantly high. Um, yeah. So I mean, there's I don't know. I mean, there's a lot of different ways you could probably think about this one. I'm thinking. I'm leaning towards A. I don't know. There's a question that came in on 5.235. Let's see if we can find that one. All right. So in 5.2, I think that's that. Okay. So that's going to be in another section, right? So let's leave this section and let's look at 5.2. And the question, I don't know if is it number 2? What number was the problem? 5.2.35. Let's see. This is this one. This seems like a good one. This seems like a good one. I think this one always comes up. It might even be on the practice. It might even be from the text as well. Let's just see if it is in our text. That way we can just warm ourselves up. There might be like an example of one of those defective rate problems. If not, it's okay. We'll just muscle our way through it. Hmm. Yeah. Well, let's see. A pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test 41 tablets. Then accept the whole batch if there is only one or none that doesn't meet the required specification. If one shipment of 4,000 aspirin tablets actually has a 5% rate of defect, what is the probability that the whole shipment will be accepted? And then, will almost all such shipments be accepted, or will many be rejected? Okay, let's think about this, how we're going to proceed. All right, here we go. So the binomial formula would be, for probability of 0, it would be 41C0 and then 0.05, 0 power, 0.95 to the 41 power plus the probability of 1. Hold on. Now we just need to see if it works or not. I mean, this is a, plug this in to the formula and see if it works. Maybe Google will have one. I mean, to do it quickly online, maybe. Let me check if we can get a. Now we're going to do this one. So the probability of success in our case is the defect rate. Charles, and this time if we get one, and Cal, it went up higher. Oh, we could have went from one and down. We could have went from one down, but that's fine. We'll add them up ourselves. So now we just have to add. We have to add those two numbers together. Hopefully this works. Let's see the calculator here. All right. 0.1220865 plus 0.2634 4499. So I got 0.3855, but they wanted 4 places. So let's see. Well, luckily we got it right. So that, all right. So the next question is, what is the probability that this whole shipment will be accepted? Well, that's just, I mean, that's just a question on, will almost all such shipments be accepted, or will many be rejected? Um, I think that just depends. I mean, this probability is actually kind of high, right? The company will accept blank percent of the shipments and will reject blank percentage of the shipments. You got it too? Yeah, that's good. That's good. What did that answer your question, or what was your question more on this one, or what else did you want to know about? Um, that was a good question. I think it's important to just be warmed up, and have the formulas ready, have your calculator ready, and just warm up and go through the problems. I mean, you know what section you're on. You're on 5.2, so you're going to be using a 5.2 type of formula when you do the problem. The defect rate was what you had to use there, and then that was pretty much it. Then it just kind of fell right out. Um, so it was really just, I guess looking back on it, really 4,000 had nothing to do with calculating the probability. This question though is really bothering me. Like, do you guys see this question? The company will accept blank percent. Does anybody get this one? The company will accept blank percent of the shipments and will reject blank percent of. Well, they're making their decision based on that batch that they sample. I mean, it seems to me that the company will. All right, let's try that. That sounds good. A little counterintuitive. So if they'll accept this, then they'll reject the other amount, which is 50. actually 61.45. All right. We got it. It's teamwork. Teamwork. That's good. You guys got that one. That was teamwork. So now we got more momentum now. We feel good now. Um, that was a good warm up. But 5-2 is a classic type of problem. And if we look at the if we go into the practice midterm, and what I'll do is I'm just going to try to print it out. So I'm just going to select a problem. You have to choose one answer and then just submit your test. And now what we need to do is we should be able to print the entire test. Okay, if not, what will end up happening is we'll have to enable that feature to where you have the ability to um, print the test. All right. So when you're reviewing it, you should be able to print off all the answers um, whenever you're reviewing it. And I think I might have did this earlier. 1 second. Okay, maybe not. Here you go. So when you get to the review part, you can um, print it and then choose print this question only or print test with correct answers. And what I'm going to do is print it to my OneNote. All right. So now we can scan through this and see what if they have a problem like that probability on the practice. We'll do this next week on our review next week, Tuesday, but this problem is going to be pulled. We're not doing these. Number 34 and number 35. Assume that when adults with smartphones are randomly selected, the probability of 64% of them use them in meetings. If 25 adults, so n is 25, and then find the probability of exactly 17. So our x is 17. So this is what you need. You need these three things, 1, 2, and 3, in order to do the problem on the calculator. So you go to distribute. I know I don't have mine here, but you go to second, you hit the second button, you go to distribute, and then you go down to binomial PDF. It's far down, and then you'll select it, and then you'll enter in the three values. Binomial PDF, you enter in 25, you enter in the probability 0.64, and you enter in 17, and it will give you the answer, 0.1547. Now, if you want to do it the long way, you can. It's going to be 25 choose 17, probability 0.64 to the 17th power, and then 0.36 to the 8 power. Now 25 combinations with 17 is this: 25 factorial over 17 factorial, and then the difference. 0.64 to the 17th power, you need a calculator to figure that out. And then times 0.36 to the 8th power. All right. That's going to be the probability of exactly 17. That's going to be the answer. And if we go back to the calculator that we got, we can enter this in. We had, the probability was 0.64. The number of trials was 25, and our success was 17. So I got 0.1547 for the exact amount. If we want 17 and lower, if we want, or no, less than 17, if we want 17 or lower, if we want greater than 17, or if we want 17 and greater. These are all of the different probabilities based on 17, but for exact 17, for the exact amount, I got 0.1547, and that's, it looks like that was good there as well. Okay, so we're we're back to knowing what we're doing. Now, on the calculator, it has binomial CDF. That's for when you want 17 or less, or you don't have to add them all up. You don't have to do exactly 17, exactly 16, exactly 15 and add them all up. You don't got to do that. You can use binomial CDF, and it will give you from 17 all the way down. But with this, we can create, but with the exact amount, the PDF, we can create the full binomial distribution table if we wanted to, by doing the exact amounts. We could say we got our X, we got our probability of X, and we put in all of them from 0, dot, 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 to 17, to 18, all the way down. Now 17, we figured it out, 157. But if we were to figure out, to complete the entire table, there's a lot because there's 25 of them all together. But if we had the full table, and then they ask us, hey, what's the probability of exactly 17? What about exactly 15? Or what about 12 and less? We can figure, using the table, we can easily calculate it all quickly if we have our table completely filled. But we don't have the table completely filled. We didn't do it using a table at all. We used the binomial formula, which is right here. And this is in your calculator as well. You can go into math and then go over to PRB, probability, and you can type in 25C17 if you don't want to do this. So there's a lot of ways to do the problem, but again, this is in your calculator as well. This is the command, and I'm pretty sure I demonstrate how to do this in the Panopto lecture video. All right. Were there any other questions? I think this was a good kind of warm up as to what we're going to be doing. And next Tuesday when we meet, and it will be recorded, we're going to be diving deeper into these questions and working them out. And if you happen to have any questions, we can talk about it. We'll eventually figure it out. It may take us a hard time to figure it out, but we'll eventually get there. We'll figure it out. And then we'll make good sense of it. But yeah, it looks like we're doing really well so far. The people are keeping up. So thanks for joining in this edition. This video will be saved for the rest of the gang and posted. And again, reach out to me if you have any questions. Spend some time with this practice, and then we will. You'll be ready for the real thing. The real thing will look like this. So if you do well on this, then you shouldn't have any problems doing the other one as well. You should be ready for the other one as well. So yeah. All right. Yeah, no problem. I think we're gonna do well. You know, we work remotely a lot, but we're always in touch. So I'm following along with the progress. Again, the odd ones like this, where the lottery, we're not going to do calculating the probability of winning and stuff like that. I don't think that's going to be on there. So we don't got to worry about number 13 either. All right. So I'm glad we were able to do this, guys, and thanks for hanging in there. This was tough. I mean, now that I think about it, even that one question with the, maybe we should add that on there. Oh, we'll be ready for it then. You'll know exactly what to do if you see one of those virus defect rates and the sampling of a small sample size. If a shipment comes in of 5,000, they're not going to test every one. They know the defect rate, and then they're simply going to take a box, check everyone in that box, and if they happen to find one in that box, or it passes. But if it's more than one, it does not pass. They reject that whole shipment, the whole 2,000. So on that note, we're going to end the call, this video, and we'll be back in touch. Reach out to me. So spend some time. This is now open. It opened today. The test will be next week. Spend some time. Next Tuesday is our time to review this some more. And so try to identify things. Make your notes. Make this be a part of your notes as well. And have your notes, have your formulas ready, have your calculator ready. And you only got one shot at it, but there's an abundance of time. I'll give you plenty of time. And plan on taking it that Wednesday or the next day, Thursday. Between one of those 2 days, anytime during those days, it's literally open for 48 hours. So you should definitely have the opportunity to take it. And it looks like the initial time for it, the initial time given, I don't know if it says it. Okay, it doesn't say it right now, but I'll go into how much time you get, but it's going to be plenty of time. Time is not going to be an issue for that as well. But yeah, guys, we're going to wrap it up here. Thanks for hanging in there. This was rough, but it sharpens us. It sharpens us. It's like it's messy. You got to get in there and figure out what the problem is really saying. Find resources. Be resourceful. Okay, like this textbook is a resource. Like notice how I found a problem similar to it, and it might have been a good idea to do that problem and then check my answer in the back of the book, because the answers to the odd problems are in the back of the book. So you just have to be resourceful, and that will help you understand it better as well. All right. Good luck, everyone. You guys will do well. Bye-bye.